Hi friends, welcome back to my channel. Today I and my friend will explain this project in a step-by-step way. That is, we have made an Arduino based sign language to speech and text conversion project to help for deaf and dumb people. We all know that sign language is mostly dependent on hand gesture recognition. The main intention of this project is to make the lifestyle of a deaf and dumb people easy. So now coming to the main component of this project is a flex sensor. Each flex sensor is applied with the initial voltage as per the movement of the fingers. According to a threshold value, what we have given in the code, if it reaches that threshold value, it will be displayed in the LCD module. And this is the final look of our project. And now coming to the components and bill of the materials. We need Arduino, LCD display, flex sensors, Wi-Fi module, and you can refer this page for more information. And this is the circuit diagram. Make connections according to it as you all do in AC and DC labs. Now let me know how to do coding for this.
Installation of Arduino. Go to Chrome, type Arduino IDE, downloaded. We download software of an Arduino IDE. Here you can download Arduino boards using Windows, Mac, Linux. These are all the options we have. If we click Windows, just download, it will be downloaded. Next, for use of Arduino, first we know for Arduino IDE app. In this, this is a previously used files, previously used programs. For a new program, we go to a files, new sketch. The general syntax of an Arduino IDE. New sketch file, new sketch. Next, here you need to select a board. Select a board on other port. We have different types of Arduinos, right? Like that, we have some. If you are selecting Arduino Mini, Arduino Micro, whatever Arduino you use, you should select that one. Arduino, I usually use Arduino UNO. That's why I selected Arduino UNO. Click OK. This is how we have. I have some code. If you want to execute, put your setup code here. It will show and put your setup code here. If you don't know, delete it. I have this code already. Next, this is a software serial.h, liquid crystal.h. This is for, it is used for and displays. This is for either some projects about sign language conversion to text. I usually use this code. Next, after selecting that, you need to compile. This button helps to use to upload to an Arduino. Before going to upload, you should put a cable here. You should put a cable that is connected to an Arduino, then you should upload like this. If you upload like this, compiling sketch, it will open. Have some error, file uploading error exists status, and copy the error message. Like this way you need to upload to an Arduino. Because I did not connected this to an Arduino Uno, that's why it is showing an error. If I connected, it will not show any error. This is a code. Like this you need to go through with an Arduino software. The code for sign language to text conversion. Here we have code breakdowns. We have first code breakdown is including required libraries. Hash includes software serial.h. This is a very important files. Hash includes serial.h. Hash include liquid crystal I2C.h. Software serial.h enables the serial communication using software, mainly for Bluetooth communication with an HC Bluetooth 5 module. Mainly for HC Bluetooth module enables and communication using software, mainly for Bluetooth communication. Liquid crystal I2C.h controls an I2C LCD display. This header file will control an LCD display. Defining components. Software serial my serial 3, 2. Next, liquid crystal I2C LCD 0 into 27, 16, 2 creates software serial my serial 3, 2 creates software serial communication on pins 3 and 2 for HC Bluetooth module. Initializes LCD display addresses 0 into 27 with 16 columns and 2 rows. 16 column with and 2 rows. Define a blue 4, define a green 5, define a red 6. Pin number 4, 5, 6 represented. Pin number 4, pin number 5, pin number 6. Pin number 4 represents a blue LED. Pin number 5 represents a green LED. 6 represents a red LED. CPP unsigned int FGH declares variables to store the flex sensor readings. To store the flex sensor readings, we used to declare a variables FGH. You can use any of the variables like A, B, C, X, Y, Z. Step function setup of void setup pin mode blue output, pin mode green output, pin mode red output configures the LED pins as an output, starts serial communication for both hardware and software. For an HC05 initializes and displays the welcome message on an LCD. It is a main loop function. Void setup for analog read A1, analog read A2, analog read A3 reads the flex sensors values from analog pins A2 and 3 in an Arduino UNO. It reads and flex sensor values in analog pin A2, 3 in an Arduino UNO. Next condition is condition 1 water request. To blink an LCD display to get a water, F less than 722, digital write, blue high, green low, red low, my serial print in, please give me a water. This is a condition. It should be displayed in LCD display. Condition 2 food request. Like that, if you for these requests we can use an if else statements. If else if statements. Else if G is less than 670, digital write green high, blue low, red low, my serial please give me a food. Condition T request. Else if we can use else if else ladder condition here. Else if else ladder. H is less than equal to 675, red high, green low, blue low, please give me a T. If flex sensors 3 values less than 675, turns on red LED, send Bluetooth message to a blue, please give me a T, displays please give me a T in an LCD display. If no condition matches, else digital red blue low, green low, red low, no flex sensor is triggered, all the LEDs remains off. Displaying general messages. If anything you want, this is a general messages, it should be displayed as you connected to a code, shows if anything you want. Summary and functionality. Flex sensors detect the bending and decide which message to display. LED indicate the different needs. Blue LED indicate water, green LED food request, red LED tea request. HC05 Bluetooth module sends a message wirelessly. I2C LCD display requests. The system continuously monitors the flex sensors and updates accordingly. Possible applications: assistive technology for disabled people, smart gesture based control for home automation, wearable tech for communication. Thank you.
After dumping the code to this Arduino UNO and by bending the specific fingers, this is the output we can see. And furthermore, there is no universal sign language for deaf and dumb people, as different regions and cultures have developed their own sign languages such as ASL, BSL, and ISL, that is American, British, and Indian Sign Languages. Since no single standard exists, new gestures can be created. So, to make easy for them, we have set the code according to what some deaf and dumb people said to us. That is, bending the index and ring finger for water, that mimics the natural action of holding a glass, while bending the middle and ring fingers for tea represents a delicate grip used when holding a teacup. And some advantages are flexibility and low power consumption. And here you can see the applications for this, that is education, healthcare, emergency situation, and public services. And for coding, check our description page. And don't forget to comment your opinion and doubts in the comment box. Watch full video to see some of the questions asked by the judges and some of my teachers. And this is definitely a prize winning project if you execute it properly. Do like and subscribe if this video helps you.